It has been known for more than 2,000 years that salt water can be made fit to drink. The old technique, evaporation, is employed in sophisticated hydrological experiments today. These hydrologists in Mexico are dealing with methods of purifying water from the sea.
We've put up this plant in a fishing village, Puerto Peñasco. It's built on a desert that runs right down to the sea. The life of this town is the sea. Food comes from the ocean, water by truck from the mountains 20 miles away. Not this. This fresh water came from the sea. We have more customers for it than we can handle. The big problem all over the world is to get fresh water out of the sea at a reasonable cost. Many methods are being tested. This is ours. We produce electricity with the power of a diesel engine. With the waste heat from the diesel, we evaporate seawater. We purify 6,000 gallons of water a day. It doesn't fill anywhere near our needs because we have a population of 5,000 people. Most of our water goes to the hospital and the school in town. Trucking water in here from the mountains costs $6 for 1,000 gallons. We get that much from the sea for $2. But that isn't all. Part of our operation is a little farm under plastic. It covers 1/9 of an acre. We pump in carbon dioxide waste from the diesel. It is fantastic the way that makes our crops grow. The fresh water we put in here stays here. In this little plot, we can grow enough vegetables a year to feed 60 people. We use 1/40th the usual amount of water. Obviously, this whole multi-purpose project is experimental, not a big production, a challenge for us, and a promising start.
In the western part of the United States, enough water is lost into the atmosphere to take care of the needs of 90 million people. This hydrological project at Lake Hefner Reservoir is an experiment in a method of keeping the water where it is needed, down in the lake. Hefner is a main water supply for the 350,000 inhabitants of Oklahoma City. This setup is an elaborate one, involving a wide array of scientific disciplines. Evaporation is an elusive problem and a costly one. Scientists have been struggling with evaporation for more than 40 years. Back in the 20s, they thought that if they colored the water with harmless dyes, it might hold the evaporation down. It didn't work, though. Here they are trying something now that seems to do the trick, putting lipstick on the water. Hexadecanol is a soft, waxy material used as a base for lipstick. It doesn't smell, it doesn't taste. They mix it with water to get it onto the lake. The system of pipes under the lake is equipped with protruding spray nozzles. Hexadecanol is a curious material. It spreads out over the surface and forms a skin only 1 molecule thick. It's economical because it only takes 8 ounces to cover 1 acre. The one big problem is how to keep it there. The worst pest is the wind. For whatever reason, insects and some animals like it. Hydrologists at Hefner have learned to keep a close eye on the wind. There are several ways of checking the amount of film covering at any given time. Something can be told from the height of the waves. Just as oil calms troubled waters, so does hexadecanol. Maintenance boats make small tears in the film, but they quickly heal. The hydrologists take temperatures of the lake, because where there is film, the heat of the sun is trapped in the water. But the big question is, how good is it? This is how good it seems to be. Radio waves beamed from one shore to the other are affected by how much water is evaporating out of the lake. So radio waves give one test. Laser beams shot across the lake analyze the moisture in the air. The results can be seen schematically. The oscilloscope in the upper right-hand corner shows the situation on the lake without the material. The laser and other measurements tell that with the material, evaporation is cut on a calm day by 50%. Most experiments like this one in Australia, Argentina, and South Africa have not proved to be economical. At Lake Hefner, the hydrologists have saved enough valuable water to pay for the experiments.